Suppose that a car is moving and at velocity, so we have a car moving with the velocity v of t. Okay, so our question, so we would like to know the displacement. What is the displacement? Okay, so that we can locate our car at each instant t. Okay, so st, let's call this displacement st. So in physics we show that there is a relationship between the displacement st and the velocity v. So the relationship, so we know that we have the derivative of the displacement equal to the velocity. Okay, like that. So for uniform, for specific movement, of course, we have this relationship. Okay, so so it is useful. So knowing a function, we would like to know a new function s, so that its derivative is vt. Such function is called we call it an antiderivative. Okay, so let's give it a definition of an antiderivative. There is definition. We call f a function f a function, so it's a function. A function capital F is called antiderivative of f on an interval I if we can check that its derivative, it will be the function, given function for all x in over the interval. Okay. The first remark we would like to give here, we have, yes, first remark. So let's give it, it's not a remark, we can put it as a theorem. So if we have f is an antiderivative, of f, then the general form of another antiderivative, of f is in the form fx, the one of you found, plus a constant. C is a constant, okay, where C is a constant. So the proof of this result uses something you know. Just I can remind you here. Here is the small proof, just a good reminder. Okay. So just a hint about the proof. Suppose that G also is an antiderivative. Another antiderivative. Derivative of f. So what happens? So that means it satisfies G prime equal f. But we know also that f prime, by definition of an antiderivative, is equal f. Then from this equality we can deduce that G prime minus f prime equal 0. But then this is exactly, you can write it G minus f prime equals 0. And you know that if it is true over an interval I on I, we saw a result in derivative that says that necessarily G minus f equal to a constant on I. Okay, so two antiderivatives of the same function, their difference is a constant, some constant. Now let's have a look at some examples that you already have know. You know some antiderivatives. Okay, so examples. Let's explore some examples. So an example, let's make a table of function f. Use f. Suggest an f capital F, an antiderivative, and then justify y. Okay, so an example. Okay, so an example of this one. The first one, for example, a power function xn. So here is fx. This is okay. Xn capital will be, so if you have x2, we know x3 over 3, because if you derive it, you get the x2. So xn will be then xn plus 1 over n plus 1, because if you derive it, you will get exactly n plus 1 xn. You reduce the power by 1 unit, and then you simplify and you get your function. Another function 1 over x, an antiderivative. We didn't do it yet. ln is ln, but you have the occasion to know it. So ln function, because if you derive the ln function, is 1 over x. So if you have already heard about this function, but what we did, cosine x, what is the, if I derive sine x, I will get the cosine x. So an antiderivative of cosine x is sine x. What about um, sine x here? Sine x. So I know if I derive cosine x, I will get minus sine x. So if I want to get minus, I can put minus here and multiply by minus. So it will be minus cosine x. The antiderivative of minus cosine is sine. What about 1 over 2 square root of x? So I know that the derivative of square root is 1 over 2 square root of x. So this is an antiderivative of this function. And more and other ways to have more. Okay, if I have another function, if I have f and g, suppose that I have f is capital F. If I have g of x is g of x, an antiderivative is g of x, then, okay, so what about f plus g? So if I have f x plus what is an antiderivative of f plus g of x, the sum function. So I know that the rules of differentiation tells me that I have this operation. That is true. So that means to the f plus g. Okay. So what about, yes, f and fx, so has an antiderivative capital F, g has a capital G as an antiderivative. What about f plus g? If I derive f plus g, I get this function, sum of these two derivatives. So what we can say, no, this is not good. This is because I have f prime of x is equal fx. The notation is confusing here. G prime of x is equal g of x. Okay, so let's write then. So I'm mixing things here. So this is not what I want to do here. So let's erase this part. It doesn't answer to my question. I'm looking for which function I need to derive. So which function that gives me fx plus g of x from this line, previous line. Okay, from this line I see that if I add f prime, f prime x plus g prime capital, I will get this function. So I can say it's f plus g of x, okay, the sum function. Similarly, for the difference, also we have this true. And finally, for constant times fx, so what will be the function that if I derive it gives me k fx? So it is clear it's a k capital fx, because we know the derivation operation. So it will be k f prime of a capital F prime x, which is this one. So k fx. Okay, so you see, you know already plenty of this function. We can deduce them easily. Okay, so now let's do just a few examples as practice to practice. Okay, so let's do an example. So you are asked to find, for example, find f such that, so find g such that you have g prime of x. Okay, we have g prime, the derivative is 4 sine x plus 2x5 minus square root of x over x. Okay, so we want to know an antiderivative of these function. Okay, the right hand side. Okay, so I see I can look at this function as a sum. Okay, sine x factor, which I know how, so I can already start say that g of x will be an antiderivative of this function plus an antiderivative of this function. Okay, an antiderivative of 4 times will be so an antiderivative of 4 times 6 will be 4 an antiderivative of sine, so it will be 4 and cosine. No, not cosine, it's minus cosine x. Remember, because minus cosine derivative equals sine x. Okay, so this is how we can see it. So let's do maybe relate about this two by dots like that. Okay, so we are treating this first group, first term. Let's now focus on the second one. The second one doesn't appear in the list here, but it is formed by something we know. So we need to work on the formula first here. We can write it differently. So we can write it as separate. So 2x5 over x minus square root of x over x, which can be simplified and written as 1 over square root of x. Then here I can work more. I can make appear the 2 and multiply by 2 so that I didn't change anything. And now I see my function as power function. I can guess. Yes, I have here x4. So I will look the antiderivative. Okay, here is the antiderivative of x4 will be something x5 over 5. 2 times, so it will be then here, so we will have plus 2 times the antiderivative of x4 is x5 over 5 minus the antiderivative of 1 over 2 is square root of x, and we have factor 2. So here is here a notation, practical notation, instead of writing capital F, speaking about the derivative, usually we denote, instead of capital of fx like that, we just put something like that. Sometimes like that, specifically we show the variable. Okay, just to say the dependence of f into the variable x, or sometimes without, if there is no confusion, we can just we can put either like that, or sometimes just f like that, not the derivative. So you can use one of those, the one that is more practical for you. So let's do another example now. So this time, look at the question. So you are asked to find again a function, but this time find find f second, okay? Find f such that you have the following information: f second of x equal 12x2 plus 6x minus 4, and such that f0 is 4 and f1 is 1. Okay. No, let's so add the information: f0 is equal 4 and f1 is 1. Okay. So before looking at these two informations, let's focus on the equation. So they gave us f second equal to function. So I need to find f. So I need to go up, find. So let's start finding f prime. Find first f prime. So I can see, I know that f prime of f prime prime will give me f second. So f prime is an antiderivative of f second. So instead of writing this just with words, just say that f prime is an antiderivative of f second. So let's find an antiderivative of f second. An antiderivative of f second is the antiderivative of 12x2 plus 6x minus 4. Okay, so I see now I look at my function. It's a sum of functions, 3 functions, and each of the first one is a scalar times a function. So I can say it's 12 times, so an antiderivative of x2 sum of functions, okay, 6x minus 4. Okay, then second step, I can say it's 12 times an antiderivative of x2 plus 6 times an antiderivative of x minus antiderivative, or 4 times 1. I can do that also. Now look at what I have here. I have here a power function. Antiderivative of x2 will be x2 plus 1 over 2 plus 1 plus 6 times here its power function, so it will be x1 power 1 over 1 plus 1. And finally minus 4, even 1 here, I can look at it as x power 0. So it will be x power 0 plus 1 over 0 plus 1. And we said all family of antiderivative are different by a constant. So let's add these numbers C, quantity C. So finally I have, yes, 12 over 3 is 4, x3, plus 6 over 2 is 3, x2, and here minus 4, x plus C. Okay, now let's find. So okay, so this is my general, my f prime of x. Okay, I can use the information, nothing. For a moment, I keep this information like that. Now let's find fx. Okay, so let's see if I can write it on this side. I will write it in this side, okay? That we don't have. Okay, let's continue here. Follow here. Okay, so let's find okay, f prime. So f prime of x, since f prime, the derivative, so f prime, if I derive now, so I'm looking to f, okay? If I derive f prime, yes, so fx is an antiderivative of f prime of x, okay? Because if you derive f, you will get f prime, okay? Okay, so we have this, so that means I can say it's an antiderivative of 4x3 minus plus 3x2 minus 4x plus c. So we do as you previously, 4 times antiderivative of x3 plus 3 times antiderivative of x2 minus 4 antiderivative of x plus c antiderivative of 1. And then 4x3 plus 1 over 3 plus 1, 3x2 plus 1 over 2 plus 1 minus 4x1 plus 1 over 1 plus 1 plus cx power 0 plus 1 over 0 plus 1 plus another constant. So let's call it c prime. Okay, and here then we have 4 over 4, so we have x4 plus 3 over 3, so x3 minus 4 over 2 minus 2 x2, and here plus c plus cx plus c prime. Okay, now finally, now to identify my function, I can use the information, substitute the information. So identify, the last step is identify c and c prime. Okay, to identify them, we use the fact that f0 is, so f0 gives me c prime, which is by assumption from the beginning they gave us the value, it's 4. Then the second information f1, which is 1, here you substitute 1 plus 1 minus 2 plus c prime equal 1, from which you deduce that that c will be 1, so here it simplifies, so 1 minus 4, which is minus 3, and you get your function completely. Okay, so this is about what we learned today, is about antiderivative, mostly definitions, examples, and operation on antiderivatives. So this is our section about antiderivatives. Antiderivative. Okay.